right, tonight we are going to work on alkanes, and pretty much all we're going to be doing tonight is learning more about alkanes and learning about naming, the IUPAC method of naming alkanes. There is a large chunk of the sapling homework that is about naming alkanes and drawing alkanes, as well as others. It's about IUPAC naming and drawing. You haven't officially been taught that yet, but that's what I'm doing tonight, okay? So what I want us to do is go through this, and then at the end of class is where we're going to really finish up with the naming and drawing, and hopefully at that point then you can go and do those homework questions and understand what you're doing. Yes, I've taught it a little bit as we've gone, but I haven't really given you the official notes, and that's what we're going to do tonight. Before we start that though, I want to ask a question about the functional groups. What is an alkyne? C, triple bond C. What is an alcohol? COH. What is an amine? CN. What is an alkene? C double bond C. What is an alkyl halide? C bonded to a halogen. You've been going on these, haven't you? That's good. And very good. What is a benzene ring? What shape? Hexagon. And then the single double rotation. Good. What is an ether? COC. COC. What is an ester? And that's fine if you put COO. Put that phone up, girl. Up. What is the actual special group that's in the ester, though? How is it bonded? Is it just C single bond O, C? C double bond O to C, or to O rather. C double bond O to another O, all right? What is an aldehyde? C double bond O to H. What is a carboxylic acid? C double bond O, OH. I've already done amide, haven't I? Amide. What's an amide? C double bond O to N. What is a ketone? C double bond O between two C's. Good. C double bond O between two C's. Did I miss any? I don't think I did. I think that's it. Okay. Please study those. Every night study those, please. Something that I've just remembered that I haven't done for you all. I did it for my morning class, but I forgot to do it for you guys. This is already on Blackboard. You just didn't know it was on Blackboard because I didn't have it opened. Some of you have asked about the final. Let me show you. Under extra practice worksheets, and this is already here. Under extra practice worksheets, this is the functional groups study. You can't see this. Why doesn't somebody holler at me? There you go. Now you can see it. All right, under this is extra practice worksheets. This is the functional group study guide I was telling you that the student came up with. It really is helpful I would encourage you to pull that off and fill in the blank one, and then look at your answer key, or not your answer key. You can look at her answer key or the student's answer key, but I would encourage you to basically print it off, the blank one, fill it in based on your notes, compare it to the answer key that the student made up, and make sure they're the same. But I do think it would really help you to do this. And also here is the final exam study guide for the comprehensive questions. There are 25 points, and it's actually 27 points. There's 9 questions, 3 points apiece, that are comprehensive. This is a study guide for that, and it's already here on Blackboard. Now, under the announcements, and I don't know that yours is open. I didn't open it. I'm not sure if I've left it open. Let me find out for you. There it is. This is a reminder. I'll just open this. This is exactly what I just told you. I'm just going to open this up so that you'll get this announcement in your email reminding you where that is. There's your reminder. And then this is your Test 5 information. I'm going to send it to you right now as well. So now, if you want to know about your final exam, there it is. You have it. Okay? Just a reminder, I've said this before, but I'm not sure that you remember, and I know it's wrong on your syllabus, but your final is Wednesday, the 6th. It says it's Wednesday the 7th. The 7th's the 8th. What did I just say? I said the 7th's the 8th. Am I totally like saying nothing right? The 7th is Thursday. Your final is Wednesday. Cheyenne, is that what did I say something else goofy too? Okay. All right. So Wednesday the 6th is when your final is. I have offered, just like I've been doing all semester, I've offered the night class. You are the night class. What is wrong with me? Well, I'm not 100% yet. I thought I was like 95. Maybe I'm just about 90. Gather your thoughts. Gather your thoughts. The 8 o'clock class, often some of them take their final exam with you at night, in the afternoon, whatever you want to call this time. Because your finals are Wednesday and Friday, and I shouldn't even tell you this until I know the if answer, but you'll remind me. That will help me. I think that I reserved Snell Hall 1108 for both classes. Cheyenne, you want to put that up? Are you just putting the final in? Are you putting in when the final is? Okay, good. Thank you. If I reserved the room 1108, if I reserved it for you guys, or I know I reserved it for the Wednesday. If I reserved it for them and theirs is on Friday, then I will allow you to come to the Friday one if you would prefer to take it Friday instead of Wednesday. I will confirm that with you. However, this is going to be the deal if we do it this way. This is not going to be a just show up when you decide you want to show up. It will be you have to tell me ahead of time, and you're sticking to the day you tell me. It's not going to be a matter of, well, can I let you know, if I show up Wednesday, I will. If not, I'll show up Friday. No, it's going to be I will know who's coming to take the exam Wednesday, and I will know who's coming to take the exam Friday. If it becomes too much of a headache, I'll just say forget it, do it at your normal time and be done with it. But I'm trying to help you out. I know finals week is usually hard. Some people like to get them all over as fast as they can. Some people prefer, because they have a lot of other exams, they would like to take it on Friday. And so that's why I'm offering it. Like I said, I am fairly certain that send me a message and ask me, will you? I'm fairly certain that I have opened or reserved that room for both classes, but I will confirm that, okay? But I'll try to make it so it's easy for all of us. All right, that I think is everything that I needed to tell you to remind you of. So, yes?
Sorry. Are you going to post the lecture videos so we can go back and look at them?
They are? What do you mean?
Maybe I just can't see them.
All these have been on there.
I looked yesterday and they weren't online.
Where are you looking?
On the, where all of them are.
Are you saying you've never seen any of these lectures?
No, I'm saying I don't see these. Like the last date I think was,
You know, he may have the dates wrong.
because it says like day, whatever.
Day 19 is the last day I think that he has, but I think that's maybe his days are wrong.
Because like,
Let's look.
I was just looking for the first one, like day 22, it said day 19.
I know he did Monday nights, and I know it's on because, so what day are we? Does anybody even know what day we are?
24, 25.
And you know this one is not it? No, because you're going to see the same thing I'm seeing. Has anybody looked at this one? Isn't it the right one? Huh? This is the right one, and the reason I know that is well, hold on a minute. Let me see. Yeah, I know it is because this was Monday night.
So that's day 22.
Whatever day it is, whatever day, I don't know if the day, I know this is Monday night. I know that. I know that because I didn't show up till like 20 minutes later. And that's what was on the board. Yeah, I can see it. You can't see it, but I'm sitting here pointing like you can see it, but I know you can't see it. I know this is the one. What may be happening is if we had, well, we had 2 days off. Remember, we had 1 day off, mole day, and there was 1 day there was no video. So if you're counting the number of days that we've actually had class, that may be why you're not exactly where this is. I don't know. I just know this one's right for Monday. So they are on there. All right, any other questions? Okay. All right, let's review alkanes. Alkanes are single bonds, all single bonds, only carbon and hydrogen. What about anything else that's not even written here that you could say about alkanes? Are they a true functional group? No, they're not really a true functional group. What can you tell me about alkanes as far as another word or another phrase we could call alkanes? Alkanes are, say that, hydrocarbons. Alkanes are hydrocarbons. Alkanes are hydrocarbons. Are they soluble in water? No, they're not soluble in water. Are they relatively low boiling points or high boiling points relative to some of the other things we've looked at? Low. Tell me something that has a high boiling point. Tell me a functional group that would have a high boiling point. Alcohols, carboxylic acids. Good, good. Now, guys, some of you, and I had the same thing happen at 8 o'clock. Some of you are just in your own little world. You're just zoning out. And, you know, that's your choice. That I can't make you do anything. But I will tell you from experience, if you will actively participate when we go through these like this, I'm doing this for your sake. I want you to learn this. And I know from personal experience how hard it was. And some of you aren't having this difficulty. You're thinking this is piece of cake. You love this. But some of you need to have this repetition. And what I'm encouraging you to do, just like we just did just now, do that yourself when you're going through these. That's what that study guide is. That's exactly what that study guide is doing. Basically, you just say each of the functional groups and then talk about them in your head. Talk about them out loud. I may have told you this before, but do you all know that most of you learn the best not by hearing somebody else talk, but by listening to yourself? When you hear yourself say it, you will remember it better than you will if anybody else says it. And so literally, I don't care how crazy you look. Sit down and say to yourself, alkanes, and then do just what you just did. Alkenes, do that again. Alkynes, do that. And then as you're doing each of those individually, do what we also did. Oh yeah, alkanes, that's a hydrocarbon. Oh yeah, the hydrocarbons are alkenes, alkynes, benzene rings are all hydrocarbons. Those are the hydrocarbons. Oh, alkanes are saturated hydrocarbons. Why are they saturated hydrocarbons? Because they all have what? Single bonds, and is hydrogen everywhere it can possibly be? Yes. Alkenes and alkynes and benzene rings, those are not saturated hydrocarbons because they have those other bonds. Well, that might make you remember, oh yeah, alkenes and alkynes and benzene rings, they are more reactive than alkanes. Do you remember us talking about that? Because those bonds can be, do you see what I'm doing? That's what will help you learn if you can start putting all that together. And it takes time. It takes time sitting down and doing that. Today we're going to look at two different types of alkanes, the acyclic alkanes, which is the chain arrangement, and the cycloalkanes. Acyclic has this as the general format. Now, I've already told you, you don't have to learn that. If you want to, that's your choice, but you don't have to learn that. Why? Because you can draw them and tell. So when we look at these two examples, our question here is, which of these is the cycloalkane? Which of these is the acyclic alkane? Another way to say what I'm saying is, which of these is the chain and which of these is a ring? If you don't know, then draw it. So start by drawing this one. Draw C5H12. What did you find out? It's a chain. So C5H12, that's a chain, no question about it. It's got 5 carbons, 12 hydrogens. What's the name of this? Pent is 5 carbons. Is it all single bonds? So what's the ending? Ane. So what's the name? Pentane. Good. Pentane. All right. Now draw C4H8. Did everyone get the sign-in sheet? I started to say it seemed like it went around fast. What are you finding out in C4H8? Did you start off just putting 4 in a row? That's what I would have done. When you did that, what'd you find out? You didn't have enough hydrogens, did you? When that happens, what does that immediately tell you? It's not a chain, it's a ring. Now, here's what some of you would probably try to do, though. You'd put a double or triple bond, which would be true if I weren't talking about alkanes. But I'm talking about alkanes, so there aren't any double or triple bonds. So it has to be a ring. And so what do? We just make a box. Good. We make a box. And then put on your hydrogens. Yes or no?
Whenever I was drawing when I did like the 4 carbons, I couldn't get like, I don't understand how you could have hydrogen.
Well, if you did it this way, I'll show you. There's 4 hydrogens, right? I haven't even put this hydrogen on. Did I say hydrogen? There's 4 carbons. I haven't even put this hydrogen on yet. 1, 2, 3, 4, 5, 6, 7, 8, 9. There would have to be 10 if it were straight. You only had 8. That's why. That's why. Could it be a diamond shape?
Yeah.
Sure. Sure. They just have to be connected. Okay? Naming, if this is pentane and it's a chain, when we have a cyclical, we simply put cyclo, and then who is a 4-carbon alkane? Bute. So it's cyclobutane. Cyclobutane. So we have pentane and cyclobutane. Just a reminder, what are the first 3 prefixes? Good. Okay, meth, eth, prop, and then it's bute, pent, hex, and they go on to what we know. Straight chain alkanes have all the carbons in a continuous chain, but we can draw them in a zigzag. For instance, how would we draw pentane? That is pentane. That is pentane. How would you draw cyclobutane? Draw a square or a diamond. Is that called a quadrilateral? That's the line structure. So the line structure, this is the Lewis structure. This is the line structure. Line structure and Lewis structure. A branched chain alkane contains one or more carbon branches bonded to a carbon chain. And then I want you to add a word here. I want you to put sometimes use prefix iso when branched. It's not always. Sometimes use the prefix iso when it is branched. We saw branched chain alkanes the first day. We talked about organic way back here. What did we have at the bottom here? You see the true branch here? Now this is a true branch. How is this a true branch? Because your longest carbon chain is 1, 2, 3, 4. That's the longest carbon chain, which makes this a true branch. Could I also say that 1, 2, 3, 4 is the longest carbon chain? Is 4 4 no matter how you look at it? So if I did 1, 2, 3, 4, is that the branch then? And that's okay. That's still the same as this, isn't it? Aren't those both methyl groups? So it could be 1, 2, 3, 4 or 1, 2, 3, 4. Regardless, that's the branch. A true branch is not part of the main chain. Sometimes, like I said, those are called iso something. And the something is however many carbons you have in the whole thing. So here I have two different compounds with the same molecular formula. Molecular formula of C4H10, molecular formula of C4H10. Condensed structure here, condensed structure here. Are they the same compound? No, they're definitely not the same compound, but they have the same molecular formula, but they're not the same compound. So the first thing I want us to do is I want us to draw them. Draw this one first. This shows you how to draw it. I think I have to start using a pencil here. All right, so our C4H10, yes or no on that one? All right, who is that? That's butane. That's butane. Okay? This one is different. It's still C4H10. And when this is given as the structural formula, what this is saying is that you have a C that has an H bonded to it, and that same C has 3 CH3s bonded to the same C. So CH and this C has a CH3 here, a CH3 there, and a CH3 here. What is the longest carbon chain in this? 3. 3 is the longest continuous carbon chain. 1, 2, 3. Now, I'm going to show you what I had to do. I'm one of these people that has to like turn when I'm giving directions. So I had to do that. Now do you see 3? And what is this truly? A branch. That's truly a branch. So if you can't see it the other way, turn your paper, and there's the 3 C's, and that's truly a branch. Is it still 10 hydrogens? There's 3, 6, 9, 10. Yes. Is it still 4 carbons? Yes. Is this definitely different than this? Yes, definitely different. What we call this compound compared to this compound is an isomer. These are isomers. And what is an isomer? It's two different compounds with the same molecular formula. And as I mentioned up here, sometimes when we have a branch, we use the prefix iso. So if this is butane, this is isobutane. So we call this one isobutane. Now that is not the IUPAC method of naming it. Now I think I've said this, but I'll say it again. IUPAC stands for International Union of Pure and Applied Chemistry. All that is I say all it is, it's a big thing, but it is, and it's a worldwide system of naming among many, many other things, standardization and everything else. But for our purposes, it is the name, it's the way to name compounds. That's what it is the way to name compounds. And so we are going to try to stick with the IUPAC method of naming, but sometimes we may not do it, and I've told you that. The ethers, those are not IUPAC method. This will be IUPAC method though. This is not necessarily an IUPAC method of naming. The IUPAC method of naming will name it with the longest continuous carbon chain, which is what? Propane. Do you see that prop is the longest continuous chain? Does that make sense? Now then, if this is the longest continuous chain, that's 3 carbons, which equals prop, and then why is it ane? Single bonds, good. This group is who? And I should have circled all of them. Methyl. Good job. That's methyl. That is methyl. It's what we call an alkyl group.
Why is there like little mini names inside of the big? Like, I just don't get what name you're looking for.
I'm not done yet.
Okay.
So this is methyl, and it is the extra thing that's attached to the main chain. But it's still one compound. Once we know who the extra things are, and once we know who the parent is, then we put it together. But to put it together, we have to decide which carbon is this extra thing on. And there's really no other choice here. It's where? 2. It's on the second carbon. If we number 1, 2, 3, it's 2. If we number 1, 2, 3, it's 2. So it doesn't matter in this case how we numbered. Bottom line, it's on the second carbon. So the name is 2-methyl propane. 2-methyl propane. That's the name of the compound. Go ahead.
So when we're naming them by the IUPAC method, we don't use the ISO?
Correct. In fact, there's pretty much only one. You will see ISO throughout your career if you go into chemistry very far, which I realize many of you aren't, but you still may see the prefix ISO. And I think it's important to realize what the prefix in itself means in chemistry. Isotopes were atoms of the same element with different masses. So they were the same but different. And that's weird, but that's what they are. They're the same but different. Isomers are the same molecular formula. That means the same number of elements, the same type of element, but they're arranged differently. which means they're a totally different compound. Isopropyl alcohol is why I'm really dealing with this much with you guys, because isopropyl alcohol is something you're going to deal with. We have all, I would say, in this room, everyone has had isopropyl alcohol rubbed on them at one time or another in their life. And so I think now, knowing, if you take a chemistry class, why not make it a little useful for you? And so what was isopropyl alcohol? It's called rubbing alcohol, but that's still not telling me anything. I want to know, what does it look like? What is it? And so that's where we're going to go today. Okay? But again, if I say something's an isomer, and you will have questions on your sapling, you're going to have questions on your test, if I will give you questions about which of the following are isomers of each other. Where are the isomers? Which are the isomers of each other? So let's look at that. So here what we have are constitutional isomers. And the constitutional isomers that we're looking at are two different compounds that have the same molecular formula, but they're put together differently. That's what a constitutional isomer is. Can you please put that up? Phone? Okay, calculator, thank you. Look like a phone. I apologize. Thank you. All right, so constitutional isomers are two different compounds with the same formula put together differently. Two different compounds with the same molecular formula put together differently. That's what a constitutional isomer is. Now, if you're thinking a little bit, think about if the fact that this is C4H10, this is C4H10, and they are put together totally differently, and that's only 4 carbons. Does anybody have like a, wow, there's a lot of organic compounds? I mean, do you realize that? Because if this is just 4 carbons and they have 2 different ways of being put together, think if you had 6 carbons. Would there be a lot of ways to put 6 carbons together even? You take 12 carbons. Oh my goodness. I mean, can you imagine? Then throw an oxygen in there. Does that make sense? Are you starting to see why organic chemistry is a huge field? It's a large, large field of chemistry. And so we are looking at this much compared to the big field, but it gets you into it enough where you may say, hey, I like this, or I hate this, whichever. And you may just stay indifferent, and that's okay too. My question here is, if constitutional isomers differ with how they're put together, then tell me on these two, are they the same? That's what we're first figuring out. Are they really isomers? In order to answer that, you first look at them and you say, well, they're definitely put together differently. But in order to know if they're isomers or not, what do you have to find out? Are they exactly the same number of carbons and the same number of oxygens and the same number of hydrogens? So add them up. What do you get? What is this? If I took it just as a straight molecular formula, what would this be? Well, give me this, not a condensed structure. Give me the just C2H6O. What's this one? C2H6O. So the question, are they constitutional isomers? Yes. Aren't they the same molecular formula but put together differently? Yes, they are. Now, I ask you here, or I make the comment, name these compounds. I am not expecting you to know how to name 100% right now. I know that. Let's name them together. In this case, what is the parent? How many carbons? 2 carbons. What's the name for 2 carbons? F. Are they single bonded together? Which makes it what? Ethane. So ethane or ethan. And what's the special group that's on this? Alcohol. This is an alcohol. And what endings do alcohols have? O-A or O-L. Yes, O-H is the alcohol, O-L is the ending. So this is ethanol. This is ethanol. What functional group is this one? In order to name it, you have to figure out what's the functional group. What functional group is this one? Ether. This is an ether. This is an ether. And I think Monday nights when we talked about this, an ether is basically what? What does it say an ether is? And I know it's used as anesthesia. That's good. If you remember anything about ether, I'm happy. But keep going. What is the general rule of thumb when you look at an ether? 2 alkyl groups attached to the same oxygen. Do you see that here? What is this alkyl group called? Methyl. What is this alkyl group called? Methyl. This is called methyl. When there are 2 of the same group, we use the prefix dimethyl. And so the name of this, and this is not an IUPAC name, is dimethyl ether. Dimethyl ether. Dimethyl ether. And that tells us the 2 alkyl groups bonded to the same oxygen are methyl. And it's an ether because it's the COC. Yes or no? The parent, the special the special thing is going to always be at an end, at the end. In other words, this is the special thing. The functional group here is the fact that it's an alcohol. And so we name it with OL at the end. F is the number of carbons. AN means those are single bonded together. I tell you what, if you'll go 3 pages over, you've got the whole list of rules. Okay? Sophia?
So are branches and
Say that again. Substituents. Branches can be substituents, yes. Branches often are the substituent, yes. Yes. Now, the next page is going to give us more examples of trying to figure out if you have a true branch or not. So this page says label each as butane or isobutane. And then I ask, okay, you have to justify why these are butane or isobutane. And then these bullets, basically what I'm saying here are ask yourself these questions. When you're trying to decide if it is an isomer, when you're trying to decide that, ask yourself these questions. Or maybe you need to say up here how to determine if an isomer. Ask yourself these questions. So does it have the same formula? That's the first question to ask. Does it have the same formula? So run through there and figure out the actual molecular formula for each of those. Count the carbons, count the hydrogens. What are you finding out? Are they all the same? What are they? C4H10. So every one of them are C4H10. Okay? So then look for the same formula. Yes, the same formula. Now, just because they have the same formula, does that automatically mean all of these are isomers? Does it mean that automatically every one of these are isobutane? No, it doesn't. Because the next thing it says, are there branches? So here's where we have to decide, do we have true branches or not? So look at A. Is that a branch? No, it's not a branch. Now some of you want to say, well, why is it down here then? Because they bent it. I mean, they just wanted to make a bend to make it look like a branch, but it's not a branch. It's a bend. So still, are these 4 carbons bonded to each other? So this is a bend. And I want to tell you the easiest way to remember or to figure out if it's a bend or a branch. And I didn't think about this until, I don't know, maybe a year ago. And I was teaching this one day and it just hit me. Do you all remember doing dot to dot? Do you remember doing the dot to dots when you were a kid? I now know why you did dot to dot. You did it for today's lecture. That's it. Your whole, they didn't, I don't know if they knew this or not, but somebody must have been an organic chemist that came up with dot to dot. Because you think about dot to dot. When you were doing dot to dot, you would have to go from one dot to the next dot to the next dot to the next dot. You didn't backtrack to come down here, did you? No, you just kept connecting the dots, and you had to stay in one continuous line connecting the dots. That's what I want you to think about. That's this. This is connect the dots. So if you have a continuous line without backtracking, then it is a true chain. If you had, for instance, and I'll show you, let's go back to one. Let's go back to this one. In this case, to connect these, you have a continuous line, right? But if I wanted to connect that one, do I have to backtrack? I would have to. So that means you don't backtrack, so that means this is truly a branch. That's how you know the difference. A bend is not a branch. Now, we're going to draw this one in a minute. I want us to look at this one. Tell me about this one. Is it a branched? No. It just happens to have 2 bends. But aren't there 4 continuously together? So again, these are bends. What about D? Bends or branches? Just bends. Good. Again, look at your C's. And you're going to say, well, why do they do that? Well, why are they doing it? To get you to see things differently. So those are bends. Which tells us then that this is C4H10 just as if I had written it out, C, 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 and then put the H's. Does that make sense? The same thing here, the same thing here. Then the question is, what about this one? It's not. Draw this. You've already drawn this once tonight. Draw it again. Draw this one. So here is my original CH. There's my original CH, and then there's a CH3 bonded to that. There's a CH3 bonded to that, and a CH3 bonded to that. That's this one. Now, is this a true branch? So which of these is isobutane? So this is isobutane, this is butane, this is butane, and this is butane. So if you're answering your questions over here, are there branches? Yes, in B. Can they be drawn differently but still mean the same thing? Yes, and that's what we're seeing here. Yes, absolutely. And that's what makes it confusing, because what you are going to be looking for is connecting carbons. Look for connecting carbons. Then other carbons coming off these will be branches. All I'm doing there is just giving you a reminder to find true branches. But connecting carbons, consistently connecting carbons, are not branches, even if they bend.
So if there's a bend, there can't be a branch?
Sure, there could be a branch, even if there's a bend. You have to find the connecting carbons and then indicate that with a highlighter, a pencil, box them in, and then if there's anything outside of that that's a carbon, that's the branch. If you have to backtrack to connect, then it's a branch. That's exactly right. This picture shows us the 3 constitutional isomers for pentane. Now, when I do things like this, when I show you examples, I'm not saying you have to memorize all of these. I'm not saying that. All I'm trying to do is start to show you ways to recognize these, because that's what you're going to have to do in your homework. That's what you're going to have to do on your test. I'm going to give you formulas or structures and say, are these isomers of each other? And what do? What's a question you ask yourself? You say, are they all the same number of carbons and hydrogens? Then you say, are they put together the same? This is telling us they're isomers, so it's obvious they all have C5H12. Every one of these are C5H12. You can count them up if you don't believe it. But it's telling us that they're isomers, so they all are C5H12. Would you all agree this is truly pentane? Yes? Yeah, that's pentane. Okay. This one is called isopentane. Why is this called isopentane? Because it has 4 continuous carbons. It still is C5H12. It has 4 continuous carbons. Does it have a true branch? Yes. Now that's not how we will name it. We will name it 2-methyl-butane. So let's talk about why is it 2-methyl-butane. What's the longest carbon chain? 4. The longest carbon chain is 4 carbons. This is the longest carbon chain. So that's 4 carbons, and 4 carbons equals what? But, it's all single bonded. That is what makes it butane. So 4 carbons makes it butane. What is on one of the carbons? Methyl. Then you say, okay, if this is methyl, which carbon is methyl on? The second carbon. It's on the second carbon. What if I told you it was on the third carbon? I'm wrong. I saw somebody shaking their head. They looked at me kind of warily, but they went ahead and shook their head, and that's good. Go against me. That would be wrong. That would be wrong. There are questions on your homework and questions on your test that will say which of the following is an incorrect name. How are you going to know if it's an incorrect name? You draw it. You draw it based on how it's named. For instance, on this one, if I had written 3-methylbutane, you would still draw it this way, wouldn't you? Because you would say 1, 2, 3 and put the methyl group there. Then you would look at it and you would say, wait a minute, it should have been named 2-methylbutane. And so then you will write the correct name. And that's why it's 2-methylbutane. This one, they call it neopentane. I'm never going to ask you about neopentane. It's an isomer, but I'm not going to ask you what was that other isomer of pentane called. It doesn't matter. If you know this is an isomer of this and this, that's what I want you to know. I want you to know how to properly name it, though. So let's learn how to properly name it. What is the longest continuous carbon chain? 3. It's only 3. Now I'm going to purposefully do something strange. You're probably saying 1, 2, 3. Yes? Or some of you did 1, 2, 3. Well, I'm going to do this. 1, 2, 3. Now, look at it for a minute. Turn your paper, flip it upside down, move your head. Is it the same thing that we all said? Isn't that exactly the same no matter how we did it? It's still the parent of who? Propane. The parent is propane. That's the parent. So the parent is propane because that's 3 carbons. The parent is propane. What is this group? Methyl. What is this group? Methyl. Which carbon are both methyls on? The second carbon. So 1, 2, 3. Both methyls are on the second carbon. When you have 2 of the same, you put di. Now here is where people think this is really redundant. Why do you have to say 2, 2 and di? I agree with you. It seems redundant, but you have to do it. Okay? So the name is 2, 2. That means there's something on the second carbon and there's something else on the second carbon. What is the something? Methyl both times. And we say that by calling it dimethyl. And it's on what? Propane. Making sense at all? These are what we call the ball and stick models. Some of you love to see those pictures that kind of are 3-dimensional. That's why I put them on. You're never going to have to draw those for me. I don't even think I put them on sapling. but some of you like that helps you. I don't like those, but some of you do, and I want you to see those. If you see this better than you see that, great. Maybe it helps you. Only thing this is telling you is adding a carbon at the end, even if you bend it, is still what? Part of the chain. Part of the chain. Okay? So it's still part of the chain. Now, all of that gets us to where some of you are already in your heads. Naming. This is the page for naming. This is my naming page. I'm not going to read the page to you. I'm going to give you just a few minutes. Read those top 3 bullet points. Based on what I have already talked about as we've been doing this for the last few days, I think all of you understand when I say parent, name, longest carbon chain. I've said that several times. So you know the longest carbon chain, that's the parent. The suffix is the functional group. Now what else could I add here that we've talked about? Ein, ein, ol, we did others. So that's what we're talking about there. I know at the top of this page it says alkane, alkene, and alkyne nomenclature. This fits for all the nomenclature. I'll talk a little more about the other later in little sections, but really this is the whole rules for all the nomenclature. Whatever functional group is present, that indicates the name. The prefix tells the identity, and we've seen this. Methyl is a prefix, but you also have to have things in front of the methyl. You'll have numbers. If you have more than one of the same thing, you use prefixes. But what are those extra things? Those extra things are called substituents, and that's a new word. I haven't used that much, if any. The term substituent is the extra thing that's on the parent. It's whatever it is on the parent. Carbon branches are substituents. And when it says see alkyl groups, that's what I'm talking about, the carbon branches. What are those names for those carbon branches? You've used them tonight. Methyl, ethyl, propyl, butyl, and you just keep going if you did a lot of them. Pentyl, hexyl, okay? That's what we're talking about when we say the alkyl groups. Your halogens could also be substituents. When we have the halogens as substituents, their names will be fluoro, chloro, bromo, iodo. That's what they will be. You just put the O at the end. That's what their names will be. Fluoro, chloro. And then this statement, these, meaning these carbon substituents, these can be isomers. And this is where I really wanted to get to for you. It's one of the things I wanted you to get out of isomers. Those alkyl groups can actually be attached in the middle instead of the end. And if the alkyl group is attached in the middle, it's called an isomer of that alkyl group. And so instead of being propyl when it's attached at the end, it would be called isopropyl. Now, let me draw that to show you what I'm talking about. We wrote down We wrote something like that earlier in this section. Do you remember doing that? We put CH3, CH2, CH2, something else. And what did we call this? Who was this if it's attached to something else? Propyl. This was propyl. This was propyl. Yes or no? Follow what I'm saying? That was propyl. Now, look at this. CH3, CH2, CH2. That's still 1, 2, 3 carbons, 3, 4, 5, 6, 7 hydrogens. 1, 2, 3 carbons, 3, 6, 7 hydrogens. These are the same, except how are they bonded? Where is it bonded? In the center, in the middle. So what is it called? Isopropyl. So if your propyl or your alkyl group is attached in the middle, it's called iso whatever it is you have. If it's attached at the end, it's just called the propyl. But if it's attached in the middle, it's called isopropyl. So here's what I want you to add. When an alkyl group is attached in the middle, it is called iso, then whatever your number of carbons is, with the ending -il. Now, you probably will want to make a few more notes than that. Sorry. When an alkyl group is attached in the middle, it is called iso, then the number of carbons, -il. So if it were butyl, how many carbons does butyl have? 4 carbons. So if it were attached on the second carbon, it would not be called butyl, but it would be called isobutyl. Go ahead. Can I finish? Let me do isopropyl alcohol. Let me do isopropyl alcohol, okay? So here's what we're talking about. In this, we call this isopropyl because it's attached in the middle to something else. So this is just a something else. R just means something else. That means something else. Here is a real example where it's not just something else. This is a real example. This is isopropyl. Now for some of you, this in itself doesn't make any sense at all. So you probably need to draw it out. I'm going to do that. Let's do it together. Who is this? Carbon. What's it bonded to? H's. Bonded to carbon. What's bonded to that middle carbon? OH, and then down at the bottom is another H, and then this is what? Again, CH3. These two equal each other. Do you understand these two equal each other? So these two equal each other. This is propyl if you are looking at it from the standpoint of the alcohol is my parent. Now this is going against what I've told you as far as the IUPAC method of naming, right? Because the IUPAC method of naming says what? Look for the longest carbon chain. So this is not going with those same rules. I think I now know why I get excited when I teach and I start like getting louder. It helps you all stay awake. More people have like had their eyes and heads nodding tonight and Monday night than they ever do. But I don't feel like getting loud tonight, okay? Just to put it bluntly, I'm kind of cranky. I mean, I really am kind of cranky, and I'm trying not to be cranky. It's not you I'm cranky at. I just don't feel 100%. I'm just kind of cranky still. And so if I start getting louder, I'm afraid I'll get like cranky sounding. I mean, I've already like gotten onto a student for a calculator, for crying out loud, you know? I mean, and she never has her phone out, so, and I kept looking at it thinking, she doesn't have a phone. Surely she doesn't have a phone. So I'm like, cranky woman. So I'm really trying not to get loud tonight because I don't want to get like mean. Okay? But try to stay awake, please. I mean, I hurt her feelings, and I'm upset about that already because I hurt her tonight because she was on a calculator, for crying out loud. You know? So I realize I'm cranky. I'm sorry. Forgive me for being a little extra cranky. I'm trying not to be. But stay awake, okay? Please stay awake. Maybe you all should, I don't want you to have what I have, but if you had what I have, you sleep for like hours, and so you actually get your rest in. That's the benefit. So, and you lose weight, you know, I mean, what more could you want, right? Sleep, lose weight, cleanse your body, no problems, right? Except you feel crazy and cranky for the week after, and you get a mouthful of fever blisters. So, yeah. Now, I've got your attention. Let's go back to chemistry, okay? Let me re-say everything I just said about that because I've lost myself. All right. Why is this called isopropyl alcohol? That's where I'm really trying to get to. Why is this called isopropyl alcohol? Because 3 is the longest chain, but this is not IUPAC naming. It's because here they're making alcohol as the parent. So they're saying this is the parent alcohol group. This is no longer propyl. Why isn't it propyl? Because it's connected in the middle. So this is isopropyl.
So how do you know?
Hold on just a minute. Hold on. Let me finish this, and then we're going to talk about IUPAC method, which is a lot easier. Okay? So this is the alcohol. This is isopropyl. Why is it called isopropyl? Because it's connected in the middle. And that's where they're getting the name isopropyl alcohol. That's where that name comes from. But that is not what we would call it properly. So now, let's name it properly. To name it properly, find the longest carbon chain. 3. So that's the longest carbon chain. Who is the longest carbon chain name? Propane, but it's a special group alcohol, so it gets propanol. And where is the alcohol? On the second carbon. So now, what's the name? 2-propanol. I like that better. Now, somebody's thinking, well, then why did you even tell us the other way? I mean, they're like shaking their head saying, this is just ridiculous. What's the point? Here's the point. Guys, you go to Walmart, you're not going to have 2-propanol on the shelf. But you're going to have isopropyl alcohol. Sorry, but those other nurses, if you say, I need some 2-propanol, why don't you know what the heck 2-propanol is? You can head bop all you want. It's not going to matter. They're going to say, sister, I don't know what the heck you're talking about. Rub this thing on their arm and give them that shot. So it doesn't matter. And you're saying, well, who cares anyway? Well, I don't know. Why are you taking chemistry? Why do you want to be a nurse? Who cares? McDonald's is hiring all the time. I banged it, didn't I? So, now, the other question.
On the exam, would 2-propanol be the correct answer?
Yes. Yes.
So it's all going to be
But, if I said, and I don't know that I say this, if I said, which of the following is isopropyl alcohol? And then I gave you choices. Can you pick out isopropyl alcohol? Do you see what and I would expect you to be able to do that because here's what your brain should be going through. Is it an isomer of propyl? What's an isomer? What's propyl? Do you see what I'm doing? What does alcohol mean? You should be able to answer which of the following is isopropyl alcohol if I ask that. I don't know that I do, don't know that I don't. You should be able to answer it. But as far as if I said to you, name this, then that's the name. Let me ask one more question before I answer any more questions. Because this is a question somebody asked me earlier today. Why do you have to put the number 2? But then the student said, could there even be a 1? Yes, and you're correct. There can be a 1. Now, draw 1 propanol. Draw 1 propanol. Draw 1 propanol. Give me more specifics.
Like instead of OH being on the second one, it'll be on the first one.
That's exactly right. That's all you do. That's exactly right.
But it's not iso because it's not in the middle anymore?
It wouldn't be. Hold on, I'm not there yet though. So that's exactly what you do. Did you hear what she said? Instead of putting the OH on the second one, where are you going to put the OH? On the first one. What if you put it on the third one? That's the first one. Okay? So that is what? 1 propanol. You have to call it 1 propanol because you can have a 2 propanol. If there's only one thing it can possibly be, then you don't have to number it. But if there's more than one thing it can be, you have to number it. I'm getting there. I'm getting there. Okay, because she's already asked that up here. I think let me tell you what I was going to say next. So, this is isopropyl alcohol in their naming system. This would be, what would this be? Propyl alcohol. If you named this one in their method, it would be propyl alcohol. Do you understand why they would say that? It's not in the middle anymore. Where is the alcohol? On the end. So in essence now, is this the same thing? Look at what I put. CH3, CH3, CH2, CH2, something else. Follow? So this would be called, in this naming, propyl alcohol. This is isopropyl alcohol. Did that answer this down here? Sophia, you had a question?
Yes, so this might sound like using on sapling.
Can, yes. But it should have been correct the other way too. Did your helper teach you that way? 2 in the middle. Okay. It should be this way correct on sapling too. This is the way we're learning it, and I apologize. I apologize. Okay? All right, the rules. These are the rules. I've done several of these. Here are the rules, though. I'm not going to read all these to you. I'm going to point out two things that I think you need to pay attention to, and that is actually down here. When you combine the substituent names and numbers plus the parent plus the suffix, you alphabetize. This is important. You alphabetize the names of the substituents, ignoring the di, tri, etc. So you alphabetize them. So here's the examples. The triethyl would come before dimethyl because what? E comes before M. Okay? And you number so that the first substituent gets the what? That's not right here. That's just we've done it. We number so that the first substituent gets the what? Lowest number. That's number 2. Number the atoms in the carbon chain to give the first substituent or double or triple bond the lower number. Maybe I need to let you read these. Why don't you read these for a minute, and then we're going to do them. All right. I found the easiest thing to do was actually to draw these before you learn how to name them. I think drawing the name is easier than naming the drawing to start with. And so let's try this. When you draw them, you draw it, in a sense, in the reverse order of the name. What do I mean? What do you think you're going to do first? Draw who? Heptane. You're going to draw heptane, which is drawing the most carbons. So find who is the parent. On this one. There's 2 different ones here. I boxed it off. We're going to do this one here and this one over here. Who's the parent on this side? So you already said it, but say it louder. I'm not hearing it now. Heptane. So how many carbons are we going to draw? Draw them. Draw 7 carbons. Draw 7 carbons. Don't worry about all the other stuff right now. Just draw the parent. Now, if we were to stop right there and throw in all of the hydrogens, that would just be heptane. Yes or no? So now we can add the stuff. So now I'm going to come back, and obviously since I'm the one drawing it, I can decide how I want to go, left to right or right to left. So I'm going to go left to right because that's what our brains usually do. So I'm going to say 1, 2, 3. What is on the 3rd carbon? A chlorine. So I'm going to put a chlorine. Now I'm only doing it in colors to show you the extra things. The blue is the parent. So chlorine is on the third carbon, but it has 5 and it says dichloro. What does that mean? There's another chlorine on the 5th one. So if that's 3, 4, 5. Now here you all want to ask, does it matter where I put it, the top or bottom? It doesn't matter. Just put it one place or the other. So that took care of 3,5-dichloro. Now what do we have? A methyl group on the third carbon. So it has to be down here. So that means there is a CH3 on the third carbon. Have I put in all the extra stuff? 3,5-dichloro, 3-methyl heptane. So I'm ready to put in the hydrogens and I'm done. You don't have to put in the lone pairs, but do remember that chlorine doesn't have hydrogen around it because it does have lone pairs. If you're going to get confused by that, then put in the lone pairs. If it's going to confuse you that it doesn't have hydrogens on it. Otherwise, come back, put in your hydrogens, and you're done. Now, look at that for a minute and see if that name makes sense. Is it the correct name? And you are asking, well, how do I know if it's the correct name? You're the one who wrote the question. I guess it is. Well, not necessarily. I might have made a mistake. How do you check if it's the correct name? You figure out, is this truly the longest carbon chain? Yes, it truly is the longest carbon chain. And then you say, well, did she number it correctly? 1, 2, 3, that's where the first substituents come out. If I had numbered it this way, would there also have been a first substituent coming off? But there'd only been 1. By doing it this direction, I got 2. So this is correct. So the name is correct. Draw this one. Now here, it's different. Go ahead. You're not going to put anything in parentheses right now, unless you had, okay, first of all, in a molecular formula, if you were just doing the straight molecular formula, you're not talking about condensed structure. You're talking about just C, however many C's. Or are you talking about a condensed structure? If you were doing a condensed structure, then if you have a section of repeating things like CH2s, then you'd put them in parentheses. Nothing here has a repeat because it's CH3, CH2, C, and it would be C with a branch Cl, branch CH3, because a condensed structure can have branches. Then CH2, CH, Cl, a branch, CH2, CH3. Nothing's repeating. Okay? All right, this is hexyne. What does that mean? It has a triple bond. Now the question is, where is the triple bond? On the second carbon. How do you know? Because what is it called? 2-hexyne. Now how did she tell you to do that? Did she do it this way too? Okay. 2-hexyne. And so the first thing you draw is 2-hexyne. That's the first thing that you draw. So 1, 2, 3, 4, 5, 6. Pick your second carbon. So who do we want our second carbon to be? I go left to right, so I'm going to say here. So put your triple bond like that. Why did I use the triple bond? It's an alkyne. How did I know it was an alkyne? Okay, because it said Y and E, all right? Why does it go here instead of on the first one? Because it's 2. That means that's where it starts. Whatever the number is where it starts. So if I were just to fill in hydrogens, what would this be? 2-hexene. Yes? So if I did nothing else but fill in hydrogens and said name that, then you'd say that's 2-hexene.
Doesn't it mean that it's at least one triple bond? So there could be
No. Now, if it said 2,4-hexene, then it would have 2. Every extra thing has to have a number. Every extra thing. And then it might even be called hexdiene. In other words, it would be 2,4 hex D-I-Y-N-E, which would be weird. And I'm not sure, I've never seen that, but I have seen diene. So it could be that. It could have diene at the end. What do we have on our 4th carbon? Ethyl. So 1, 2, 3, 4. And what is ethyl? CH2, CH3. Now before we're finished, I want us to do something. Is this the proper name? How do we know? 1, 2, that made it hexene. 3, 4, 5, 6, so that's a long chain. What if I went 1, 2, 3, 4, 5, 6? That's still 2-hexene, isn't it? And who is this then if this were my longest chain? Who is this? Is that still ethyl? So it's still the same. If I did 1, 2, 3, 4, 5, then that's definitely not the longest chain. And your longest chain has to have the extra thing in it, if there is an extra thing. Let me explain that. You could not have an alkyl group with an alkene or an alkyne in it. Does that make sense? In other words, this could not be the longest chain and then this be an alkyl group, because that has an alkyne in it. You can't have an alkyne as an alkyl group. So this is a correct name. Put in your hydrogens, and don't add too many hydrogens. Don't add too many. So put in your hydrogens. Does the second carbon get any hydrogens? What about the third? What about the fourth? It gets 1. Go ahead. Say that one more time.
when you're counting for the carbon chain, how many there are, like which way you're going to count?
The extra thing, which could be the double or triple bond, has to have the lowest number.
Would there ever be like a substituent and a double or triple bond?
This one does have one. This one has a substituent and a double or triple bond, and so that's why it was numbered left to right.
Well, that one, because we threw off the name, but if you were...
If I gave you this one and said name it, if I gave you this and said name it, then what you're doing is you're saying 1, 2, 3, 4, 5, 6. If I did it this way, 1, 2, 3, 4, 5, 6, then you would say, well, hey, 1, 2, 3, that's ethyl off the third one. But still, look at this, 1, 2, this is the lower number. And if they are the same, or if you have a lower number, let's see, if you go with the lowest number on the substituent possible, the first lowest number, the first substituent, the first extra thing gets the lowest number, bottom line. Okay? Flip the page. Now, some of you are totally bored, aggravated, could care less. Some of you are like, this is kind of neat. I'm getting it. This is kind of fun. Now, some of you are still confused and in between. Let me show you how confused and in between I was. There are two funny things about this next question. Anybody want to tell me the weird, funny thing of this? What did I do? Say that again? Well, the mouse, yeah, the mouse is on there. It's right there. It's a copy and paste thing. But that's not the funniest thing. I mean, there's lots of mistakes there. Well, hold on a minute. The obvious that I wanted you to see, what was this whole thing? We were learning how to name or learning how to draw, right? What did I do here? I gave you the answer. I mean, there's the answer right there. I gave it to you. But then there is something else funny. And I think you got it. What else is funny about it? Opposite of what? Okay. Then you still haven't gotten it. That's okay. You haven't gotten it. It's okay that you haven't. You're going to get it in just a minute. Cover it up. Name it. Cover up the answer and name it. Then you'll see how silly I was and what I just did. Cover it up and name it. This little comment at the top where it says more substituents on C3, that is helping you know that you're supposed to number from right to left. That's what that's telling you to do. So I've covered it up. You name it. What's the longest parent chain? 7. Okay, so this is my longest parent chain. It's all single bonds, so that's going to be what? Heptane. That's heptane. And then, this is Cl, by the way. The mouse is in the way, but that's Cl. So what do we call this one? Chloro. What will this be called? Chloro. So there are 2 chloros. That's going to be dichloro. What is this group called? Methyl. So this is a methyl. And then this tells you there are more substituents on C3 if we number it in this direction. That's why you number it in this direction. So what's the name going to be? What's your parent? Your parent is heptane. Alphabetically, who comes first? Chloro. So what are our numbers? 3, 5 dash dichloro dash. What number for methyl? 3 dash methyl heptane. Now, uncovered, is that the right answer? Now, flip your page back to the previous page. Do you see my stupidity? What did I do? Just exactly the same one. But see, you all didn't get it either. Of course, you think the teacher would, but do you remember I told you the teacher didn't know what she was doing when she first did this? I need to redo my notes, I know. But it's funny because you all don't get it either, so. And that's okay. I don't laugh at you because I was the one who did it. Pretty dumb. This one's different. This one is different. See if you can name this one. See if you can name this one. if you're struggling with what to do, circle the longest parent chain and then name the longest parent chain. Who is the longest parent chain? So, and you can do it this way. That's the only way I think you could even do it. You could bend it here, but again, that's just being silly, really. You don't need to. So it's 1, 2, 3, 4, 5, 6, 7, 8. That's octane. Now circle your substituents and name them. Circle the substituents and name them. So who are these substituents? And who is this one? This is ethyl, this is methyl, and this is methyl. And then you say, number them so that the first extra thing has the lowest number. So are we going to number left to right or right to left? Left to right. Because if we numbered it right to left, it'd be 1, 2, 3. Here we go 1, 2. So we number it 1, 2, 3, 4, 5, 6, 7, and 8. Now who comes first? Ethyl. How many ethyls do we have? Only one. And what number is it? So it is 5 dash ethyl dash 2 comma 6 dash dimethyl octane. Yes or no?
So for the test, is this the only type of naming we need to be able to do?
We're not through all the notes, so no. But this is,
Like, do we need to know how to do that?
the IUPAC, this is the IUPAC naming. No. Thank you, Vicki. Except for, like I already said, if I listed, I think you just said, well, why do we even look at it then? Because I already said that. Isopropyl alcohol. You need to know what an isomer is, so you need to know why that's called isopropyl alcohol. This is how I teach. If I know something in real life and I can explain it and why it's like that, to me, that's useful information. I know some of you don't think so, but I do. That's how I teach. If you didn't like it, sorry. It's too late now. Okay? But that's how I learn, is if it's useful. You had a question?
Why didn't you name the methyl on 5? Because there's an ethyl in them. You only named 2 and 6. But there's one on 5, right?
No, there is no there is an ethyl on 5. There's not a methyl on 5.
The CH3 is not about the methyls on the end.
This methyl is on 6.
Right. Then the one beside the ethyl on top on 5.
This whole thing is ethyl. Ethyl is 2 carbons. This is ethyl. I know what you were seeing. You thought I was calling CH2 ethyl. No, CH3, CH2 is ethyl. Okay? That's okay.
What do we do with those hydrogens?
As far as like naming them, you don't ever name hydrogens because hydrogen's the filler. There's going to be hydrogen in it. Just know it's there. Hydrogens are always connected to the carbons to fill them up. That's just a given. That was back, in a sense, why I said that first day, all organic compounds contain carbon, most contain hydrogen. The extra things are the things we're concerned about. The givens are the fact that it's going to have hydrogen, it's going to have carbon. That's the only thing I don't talk about. Yes. 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 There was another question.
Okay, can you just go over one time again why we go from left to right? Like you said lowest number, but I don't. Yeah.
The lowest number, the extra thing needs to have the lowest number. So if this is my parent chain, this is an extra thing, and I'll circle all the extra things. Those are my 3 extra things. And again, I know the hydrogens are, that's what I think she was saying, why don't we talk about hydrogens? They're extra. Hydrogen's going to be there. Don't worry about hydrogen. This extra thing called methyl is on the 2nd carbon if I number it in this direction. If I numbered it in this direction, the extra thing is on the 3rd carbon.
So that's how you determine if
1, 2, 3. Here it's 1, 2. Whichever one has the lowest, the way it has the lowest number. Number so that your extra thing has the lowest number. It doesn't matter which way you number it, as long as you number it so that the extra thing gets the lowest number. In other words, they aren't going to say, always number these left to right. Because sometimes when you number left to right, that's not the lowest numbering way.
But it has to be the lowest number.
The extra thing has to have the lowest number, so it doesn't matter which way you number it, as long as the extra thing has the lowest number. That's what it means when it says it doesn't matter which way you number. Because most of us would have always numbered left to right, because that's how we read. That's why it's saying that.
I thought with you saying that, you could say, like, you meant that you could also, like, on that specific structure, that you could also do the right to left.
You can't, because if you numbered it right to left, then this would make the extra thing have a 3, and that's not the lowest way possible. Okay? Go ahead.
If each extra thing starts on let's say the number 2 on each side, but
Then you go with alphabetical. The question is if each extra thing is on, say, a 2 on each side, then you would go with alphabetical. So for instance, if this ethyl were over here on the 7th carbon, and the methyl were on the 2nd one, then you would number right to left because E comes before M. I'm hearing 2 different ones. Go ahead.
You start out with lowest number, and then you would look at most substituents, and then if there were only one, then you would go.
You would start off with lowest number. Which one has alphabetically lowest number? Lowest number, period, then alphabetical, then the number that there are, probably.
Wait, but on the first one, isn't
The first one here, is this, okay.
doesn't chloro alphabetically before? So what do you number this way? Because
But
technically they both are the third one.
I agree. That's why, but, so that was that's what she was just saying. If you, and then she said the same thing. If they have 2 things, they're both on a 3. So this is on 3 and this is on 3. Then how did we know to number it right to left in this case? Because if we numbered it right to left, we got 2 things on 3. So it has more than one.
So alphabetical, because there's chloro on both, so that would be right. So then,
What if it was like methyl and chloro?
Then you go with chloro. Alphabetical.
I just trying to show which one to look at first.
Lowest number, look at lowest number, then alphabetical. If they're different, then alphabetical. Let's say that they're all different. They're all the same or they're, I don't even know what to say now. Just go with the most that has the lowest number and or alphabetical.
Okay.
Let me tell you what you need to do. You need to do more. Okay? Now, some of you have not ever looked at that free textbook, and honestly, you probably didn't need to, but I think some of you need to now. You need to go to the chapters at the end, which are like 11, 12, 13, 14. Go to those pages where it shows, and that book is good because it gives you, just like I've done, it gives you the structure and it gives you the answer. Cover it up, try to do it. Uncover it, try to do it the other way. That's what will help you learn, okay? So try it. I will see you Monday.